Okay, so let's try to solve this problem number 91, decode ways. So you have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping. So basically 1 is equal to A, 2 is equal to B, and similar way 25 like this way, 25 equal to Y, and 26 is equal to Z. So basically it's giving the this 26 basically the position in the the position number in the English alphabet. Like we have one is for A, 2 is for B, similar way 26 for Z, 25 equal to Y, like that. Okay. However, while decoding the message, you realize that there are many different ways you can decode the message because some codes are contained in other codes. So, like for example, 2 and 5 versus 2 5. So, so 2 we can decode, 5 we can decode, and 2 5 we can decode. So 25 I think we can decode two ways. So let's take few examples over here. 101. So 10 we can decode as J. 110 we can decode as J, and then 1 we can decode as A, right? And 101 01 we cannot decode because it says like whichever string starts with 0 we cannot decode. So 01 we don't, it's not 0 is not relevant position number in the alphabet series, right? So we cannot put we cannot decode 0. So this 01 is not possible. 01 is not possible, and 1 was possible, 1 is possible, but 01 is not possible, so we cannot decode. So number of ways we can decode this 101 is only single way. Okay, 1. 909 909. Now 90 is not a valid number because it is not a valid position, in the sense like it is not a we have alphabet, we have the position numbers from 1 to 26, so it's basically greater than 26. That's why we cannot decode this. Okay, 9 we can decode, but as 26 as 90 we cannot decode, so basically it's not possible. Again, like if you are doing with simple single line and 09, 9 we can decode, but 09 as it starts with 0, so you cannot decode it. Okay, so basically whenever we are getting a 0, whether we can decode or encode, it depends on the characters or the digits on the both the sides. For example, 101 we can decode, but 909 we cannot decode. Okay, now let's take another example, 18. Okay, so 18, the position number, it denotes the letter or the alphabet as R. Okay, and 1 denotes as A denotes as H. So basically we can decode 18 as two ways. Okay, now 06, if you are getting an example, 0 we cannot decode, so basically number of ways is 0 only. Number of ways to decode is 0 only. Now this problem, like whatever this problem, so this problem say that we need to decode or need to get the number of ways to decode, right? Number of ways to decode a string. Now when this kind of keyword we can find, like we can think of taking recursion, right? Because we need to find the all possible ways, so we can do it with recursion, and then if there are overlapping subproblems we can optimize with dynamic programming, right? Now let's take an example over here. Okay, so 2 2 2 5. Okay, so as we the number is 1 and the alphabet position is 1 and it can go up to 26, right? So you can either take one character one character in this string, right? Or we can take two characters or two characters in the string, right? But it should be less than equal to 26. Okay, so on this, right, so let's decode like this way. Okay, so if we decode the first character 2, okay, so remaining would be 2 to 5. Okay, and if we decide like, okay, we will not decode 2, we will decode 22, right? And 22 is less than equal to 26, right? So you can do that way also, right? 22 and remaining is 25. Okay, now 2 to 5 again. So this is, we have taken one position plus 1 and we have taken two positions. Okay, so basically we can say it is index plus 1 or index plus whatever. If it is a starting index 0, so index plus 1 and index plus 2. Okay, so index to index plus 1 we have taken, and another is the index to index plus 2 we have taken, right? Okay, then we'll go to next. Okay, so remaining is 2 to 5. Okay, so we can again decode 2 and remaining will be 25. And if we decide, okay, we'll decode 22, then remaining will be 5. Okay, 2's relevant position is B, 22's relevant position is V. Okay, similarly over here also 2 is B and 22 is V. Okay, then again we can, so remaining over here is 25. So 25 we can decode as 2, remaining will be 5, and another is 25, which is less than or equal to 26. So 25 is basically Y, 2 is B over here, right? Okay, remaining is 5. Okay, so 5 we can decode completely and there is no remaining over here. So 5 relevant position is E. Okay, this is also conjugated over here, so Y. Okay, then over here 5 is remaining, so 5 again is denotes is E. Okay, and over here remaining was 25, right? 25 we can denote, we can decode as 2. First we can decode 2 and remaining will be 5, and if we decide like we will not decode 2, we will decode 25, then there will be an option as Y. Okay, and this 2's relevant position is B, relevant character is B. Okay, then over here 5 and remaining is 5. 5 we can decode as 5 we can decode as E. Okay, so how many ways? So one is B, B, so this B, this B, this B, this B, so triple B, E. Next is, if you are taking this path, so double B and Y. Okay, next is B, V, E, so B, V, E, so this one B, V, E. Okay, another is V, B, E, V, B, E, another is V, Y, right? So how many ways? 1 2 3 4 5. So 5 ways. So 5 we need to return. Okay, now we can see over here, so let's take a different color. So you can see over here, 25, right? So 25 is matching with 25 over here. Okay, this 5 is matching with this 5 over here, right? So there are overlapping subproblems. So if you have pre-calculated for 25 as 25, we can decode as B, E and Y. So we do not have to decode again, right, 25 again, because if you already know the result, then we don't have to decode this again. So so basically, if you keep it in the memory, or if we memorize the value, then we don't have to do this again and again, right? So if there are overlapping subproblems, then we can think of optimizing the problem with dynamic programming, right? Okay, so over here we will take recursion with memoization, okay, or the top-down dynamic programming. Okay, so how many ways we can put over here? So if we take a function over here, so f of index plus 1 and f of index plus 2, so basically we can say like f of index plus 1 comma pass the string. So this will give the number of ways. So this particular portion will give number of ways. Okay, and then we need to add the second part, this part also, right? So then again f of index plus 2 comma s. Okay, so basically if, and this provided this index plus 2 is less than or equal to 26, and if we add this together, if we call this function together, then I think we can get the number of ways, right? Okay, so basically we are taking we are moving one depth, or we can say like go depth, taking one digit, and go depth taking 2 digit, right? Okay, but provided it should be less than or equal to 26. Okay, now what will be the base cases? We got the number of ways. Now what will be the base cases? Okay, so if the starting position, if the starting index reached at the end of the string, basically this index is reached the end of the string, then we can return 1. We got one way to decode the string. Okay, next, if the starting index is 0, we cannot decode it, right? So if the starting index is 0, we can return 0, right? Okay, so let's take a function over here, dfs. So going depthwise. Okay, dfs, so we'll pass start index. Okay, so this function will expect start index, then the string. Okay, and we can pass a dp array. Okay, now dp array, we can declare a dp array of 1d array. So 1d array we can declare. okay, and we can initialize with, and size would be n, or the digits length, string length, okay. So if the string length is n, so we can declare a dp of size n and initialize with 1, -1, initialize with -1, okay. And this dp will pass to this dfs function, okay. Now first base case. So first base case is if start index is equal to s dot length or s dot size. If we reach to the end of the string, then we can return 1, simply return 1, okay. Now if you have already pre-computed the value, of if you have already memoized the value, right, then we can return whatever we stored into this one day dp table, okay. So if says like if dp of start index not is equal to -1, then we can return dp of start index, okay. This is done. So we return the memoized value. We have done the if the starting register, this part is done. So this part is done, okay. The remaining base condition is if the starting index is 0. So basically we can say if s of start index is equal to 0, then we can return 0, okay. Next we can declare a variable ways is equal to 0, okay. Now so we need to move either one position or two position, right? So you can say weights plus dfs of start index plus 1 comma s comma dp, okay. So this will handle this part, the first part, okay. Now we need to do the second part, okay. But while going for the second part, we need to do couple of checks, okay. First thing is like whenever you are taking the GDs, it should not be out of bound, okay. So you can say like whenever taking if start index plus 2, so here I am taking start index plus 2, it should not reach beyond limit. So basically it should be less than is equal to digits dot length, it should not be out of boundary, okay. And it should be within 26, right, whatever the two characters we are taking. So for example 18 or 25, so basically whatever you are taking, it should be within limit of 26, okay. So you can say another condition, and parseInt into parseInt the substring we are taking from start position to start index plus 2, okay. So you can say s dot substring start index to start index plus 2, okay, plus 2, okay. So this should be less than is equal to, this should be less than is equal to 26, okay. And if both the conditions are satisfied, so this condition my bad, so this condition is satisfied, so it is within boundary, and this is within less than or equal to 26. Okay, what about the two characters, two letters, two digits we are taking, so that is within 26, then we can add the ways. We can add the ways over here. So ways plus is equal to DFS of start index plus 2 comma s comma dp. Okay, and finally, while returning from DFS, we can memoize the value into the dp array or dp table. So we can return dp start index is equal to the number of ways. So we are returning the number of ways as well as we are keeping into the memory as well. Okay, so I think, and then if we call this function DFS with start position as 0 and pass the string and pass dp, okay, I think we'll get our result. Okay, and what will be the time complexity for this solution? So time complexity would be O of n. Okay, space complexity would be O of n, because we are taking a 1D DP array, or DP table, and also we are using the auxiliary stack space. Okay, so this is for auxiliary stack space, and this is for the 1D DP table. Okay.